Hello everyone, welcome to this video where we're going to be talking about the Indian code implementation for the generation of seismic and wind loads. And the example that I'm going to be using here, as you can see, is a multi-story steel frame structure. I have rigid diaphragms on the floor, which I can just turn on the diaphragm nodes to verify that those nodes are all constrained to act as a rigid set in plane. I've also got an opening in here, I've got some bracing and whatnot. And in order to efficiently create these loads, it is important that we actually set up our floor IDs. Now, depending on how you built the model, this might be done for you automatically, but can also be applied manually as well. So I'm going to go just to this floor plan tool, and we can see here the floor IDs assigned to each level in my structure. This will help S-FRAME know where one level begins and the other ends. Again, this can be applied after the fact. If your model doesn't have this, you can manipulate the data that's already in there. But this is just going to help make things a little bit more efficient. Now I can go to the settings menu under preferences, and we can initialize some of the data related to our load generation. So that's done under the design codes tab here in the preferences window. You can see here I specified the building code, and at the bottom we have two different tabs. We have this tab that has the E tag on the end of it, as well as W. So E stands for earthquake, W stands for wind. We'll start with wind, and we can see here we have some wind coefficients defined. So we have a wind speed defined, as well as different exposure types available to us that we can select. We can define things like our probability and directionality factors, as well as our wind pressure coefficients, which are defined on an axis basis, so along the X or the Y direction, on the windward or leeward side of our structure. These are all defined by you, the user. Now I'll switch gears to the earthquake tab, and you can see that we have additional parameters that we can define. So there's earthquake site specifics like the earthquake zone, which I've set to 2, the soil profile type, which I've set to 1. As you can see, there are other options available to us to control. We can also specify parameters related to our fundamental period in the X and Y axis, our modification factors, seismic zone factors, and more. So I'm going to click OK to accept all these parameters, and I'm going to walk through how we can actually start applying these loads and generating them. And that's done through the loads window. So I can click to the loads window, and you'll see that I already have 3 load cases in my model. I'm going to add a few more though. So I'm going to start with the wind loading. And now that I've got all those parameters set up through the settings preferences dialog, I can actually just go to the edit menu, and I can say generate and close structure wind loads. So I'll click on this option here, and it brings up a dialog that asks me, do I want to generate the wind load cases for the lateral loads, and do I want to update any existing load cases that might have already existed. So for example, maybe I generated this before and I've added a modification to the structure. I can actually update those and just specify which load case range I want to replace with those wind loads. I'm also going to give this load case group here a name. I'm going to say wind, so that any wind load case I generate will have the word wind in front of it. And then I can click OK. And just like that, you can see here now I've got 4 additional load cases in different directions, as you can see with the plus and minus symbols. And I can look at the parameters associated, or the loads associated with each as well. So I can toggle on the display of my joint loads, and I can see here the magnitudes of those loads as well. So in each direction, what those magnitudes are throughout the different floor IDs. Now this is how we define the wind loads, and obviously we can run an analysis. We can combine these loads with different load cases to generate our load combinations. Now let's go ahead and look at our seismic loads. So I'm actually going to start this process by actually creating a new load case. So just look at the X direction for this example. I'm going to click on a new load case, and I'm going to call this RSA-X. And with this load case, I want to just go ahead and define a response spectrum curve. And we can click on this response spectrum tool, specifically right click on this tool, right on the left hand side of the screen. And it will bring up this response spectrum analysis dialog that will serve as kind of the focal point for all of the things related to our spectral response curve. I'm going to actually click on this chart button at the bottom of the screen and start specifying my response spectrum curve. So we have this response spectrum file that opens up, a dialog that opens up rather. And here we have different ways of defining our response spectrum curve. We can enter the period and acceleration at within this table here if we want to manually create this file. We can also import curves that might have been created already or we received from a colleague, for example. And another option is we can click on this codes option. And here I've selected the Indian building code. And this, out of all the codes that we support, has the fewest inputs that we need to enter. We just specified the soil profile type that we're going to use and click the generate button. And S-FRAME will generate this curve for us based off those inputs. I can give the curve a name. I can save the curve once I'm done. So I'm just going to click the OK button. You'll notice here that this actually displays the acceleration versus period. Note that acceleration is in meters per second squared units. So I'll click the OK button. I'm going to save the changes. And the file that I save will be accessible within multiple models. So I can reference multiple from multiple S-FRAME files. I can reference the same response spectrum curve. Here I can see my curve actually displayed. I can change tabs here and go to select my modal combination method, my spatial combination method, and which direction I want this curve to be applied in. And say the X scale direction and a critical damping ratio of 0.05. Now I click OK, and I'm now able to go ahead and run my analysis. So I'm going to run an unstressed response spectrum analysis that allows me to look at the vibration characteristics, the modal analysis results, learn which modes have which natural frequency or period, and mass participation, and use that to calculate the base shears on my structure. So here I'm going to click OK to run the analysis. And the solver is run. I'm now in the graphical results window. Here I can look at my RSA load case. And I can actually display here the joint loads on each floor. You can see they're apportioned at the rigid diaphragm mass joint. I can see things like my base shears, so how much base shear I'm getting in each direction. As well as I can go into the numerical results and I can look at similar data. I can look at also at things like the base shears like I saw earlier. I can look at the interstory drifts in my structure and the percentage of the story height, as well as the floor forces and torsional sensitivity and so on for my particular structure. And if I return to the loads window, I can now go to the edit menu and I can choose to generate equivalent static loads from my RSA load case. And from here you can see that I can select my RSA case. I might have more than one. I can select more than one if I want to, and I can choose to extract the equivalent loads for the equivalent lateral loads, torsional loads, or both lateral and torsional loads. So I'll click OK. And you can see it's generated some extra load cases for us. Lateral force, this is a strength EQX, lateral force plus torsion, and lateral force minus torsion. And we can see those values associated with that here. So we can get a pretty good understanding of what the demands are on our structure from this type of loading and at different floor forces, or floor locations as well. Now we have a lot more information available on our seismic and dynamic analysis. If you're curious, please check out the Altair Learning Management System for more information.